Hello, this is Dr. K. Welcome to Module 2 of Software Engineering. This module is based on Chapters 3 and 4 of Software Engineering, a Practitioner's Approach by Roger Pressman and Bruce Maxim. In this video, we're going to talk about what is arguably the most important, certainly the most vilified, and possibly still the most widely used process model in all of software engineering, the waterfall model. The waterfall model belongs to a class of process models that Pressman calls prescriptive models. The word prescriptive can mean to suggest or recommend, but it also has another more authoritative meaning, and that is to stipulate or to specify or dictate what somebody should do. It's this second meaning that's captured here. Prescriptive models offer a disciplined, ordered, and structured approach to developing software. But there's a potential problem with this. Remember in a previous video, we talked about how the one thing we could depend on in software development was that our software was going to change. And if change is so pervasive in software engineering, should we really be relying on a software process that strives for order and structure? Maybe we should be thinking more about processes that are flexible and can adapt to changing requirements and changing environments. On the other hand, would a flexible process give us the discipline we need to create a quality product? Maybe it seems like Pressman is asking us to choose here between alternatives that we haven't even seen yet. Well, that's exactly what's happening. The first alternative, prescriptive processes, are what we're going to look at in this week's module. The second alternative, agile development, is something we'll look at in next week's module. However, this question of structure versus flexibility is a good thing to keep in the back of your mind as we explore the different process models over the next 2 weeks. Let's remind ourselves what a generic process model looks like. It's made up of a sequence of framework activities, and each of those framework activities have multiple actions associated with them. And each of those actions involve a set of tasks to be performed, work products to deliver, milestones to meet, and quality assurance checkpoints to satisfy. In contrast to framework activities, umbrella activities are activities that are performed throughout the entire process. Some examples are project tracking, risk management, quality assurance, and configuration or change management. So we have a sequence of framework activities performed in a specific order, and we also have umbrella activities that are performed throughout the process. Now let's see how good your memory is. In last week's module, we mentioned specifically how many framework activities were in a generic process. And furthermore, we learned the names of each of those framework activities. So, can you tell me, if I give you 10 seconds, or you can pause the video, how many framework activities there are, and give me their names in the order that they are performed? Okay, ready? Here's the answer. There are 5 framework activities: communication, planning, modeling, construction, and deployment. Communication deals primarily with requirements gathering. Planning is estimation and scheduling. Modeling is requirements analysis and design, which includes architecture. Construction is coding and testing, and deployment is delivery and feedback. This is information you should know without having to look it up. Remember what Pressman says about these 5 framework activities, that they will all be present to a greater or lesser degree in every process model that we're going to look at. So let's start looking at process models. The simplest process model is comprised of these framework activities performed sequentially in the order given here, one after the other, starting with communication at the beginning of the project and ending with delivery. And the model is often represented like this. And the name of this process model is the waterfall model, because it looks like a waterfall. So let me step you through an example of a project that uses the waterfall model. This is a relatively small project, and it's going to take about a year. Someone in the company has a good idea for a software product. A team of the right people get together, and they decide to go forward with the idea. Requirements engineers are brought in to talk to the customers, who happen to be internal to the company in this project, and they gather the requirements. And let's just say this all takes about a month. Then the business analysts come in, and they estimate the amount of time and money the project is going to take. Management looks at the numbers and gives them the go-ahead. This whole planning process takes, again, about a month. Now the requirements engineers can analyze the requirements they gathered, which takes them, guess what, another month. Once they're finished, the design team works off the analysis model and creates an architecture and a design model for the project. The design phase takes about 2 months. And once that's finished, we can start implementing the design. So the programmers come in and spend about 2 months implementing the design model. Testing takes a little longer. It's about 4 additional months before the testing team, working with the programmers, are satisfied that the product meets all of the original requirements. Getting everything ready for deployment takes about a month. The product is delivered, the customer sees it, and everyone's happy. So, here is another question for you. What could possibly go wrong with the waterfall process model? Or, if you wish, just try to think of some disadvantages of the scenario that I just described. Ready? The most serious problem with the scenario I described was that the customer, and remember, the customer is the one who's setting the requirements. The customer is involved only during requirements gathering and delivery or deployment. And if it turns out that there was a problem with the requirements, or more realistically, if it turns out that the customer requirements have changed during the course of the year or so it took to build the software, then you're going to have a problem at delivery. In general, if a problem occurs in any one of these activities, and if it's not found until you get to another activity, then you're going to have a problem. And the larger the gap between the activity where the problem occurred and the activity where the problem was found, the bigger the problem becomes, and the more difficult and the more expensive it is to fix. And the biggest problem is with requirements, because requirements change. Here's an older slide from Pressman about waterfall model assumptions. Notice that the first 5 bullets all have to do with requirements. Essentially, you can rephrase these 5 bullets as The requirements are well understood in advance and will not change very much. Now, that is a huge assumption. And quite honestly, it's not a very good assumption in software development. So that is a serious problem with the waterfall model. And that's it for Pressman's view of the waterfall model. We'll talk more about the waterfall model in the next video, and we'll see a slightly different view of the waterfall, and we'll look at some software engineering data based on that view.